Alright, so we're going to cover factoring here. Our first example is a tougher looking one. First we have to recognize from our steps, is this in order? Yeah, we have a variable with the highest exponent is the first term, variable with next highest exponent, and then the constants last. So we got that checked. We look for a greatest common factor.
We need to divide everything by -3.
Yes, that's right. We're going to divide everything. Now technically 3 itself just works, okay? But when we do our factoring, it's going to be easiest if our x squared is a positive term. So since it's negative right now, we're going to divide by a negative number. We always want to keep that first term as a positive number, okay? So we're going to divide each by -3. So where does that 3 go?
Outside the bracket.
Yeah. So we got -3 outside, and then what do we get?
6x squared.
Yep.
11x, -11x.
Good. Good. Okay. So we got order terms, check. Greatest common factor, check. Is this a special factor? In other words, is it a difference of squares? What we have here in the brackets. Is this a difference of squares? No. We got 3 terms, right? A difference of squares. A difference of squares has only 2 terms, and there's a subtraction sign between. Okay? So we got 3 terms. We know we're not dealing with that special factor.
So it'll be like this.
Yeah, exactly. That's the next thing we're going to check. And finally, factoring by products. Okay? So you're going to tell me if your teacher's used to seeing it this way, but what we'll do is we're going to find the factors of our first a term, okay, which we have there. Now, factors of 6 are 1 and 6 and 2 and 3. Now, technically, because it's x squared, it's not just 1 and 6 and 2 and 3. Yeah, let's put an x involved with that. So we have 1x times 6x and 2x times 3x. Okay, so we have those terms. Now we look for the terms of our c, which is 10. Now here,
5 and 2.
Yep, we have 5 and 2. And what else?
10 and 1.
10 and 1. Okay. So we got to find the products of these two terms. So this is how we're going to set it up. We have our factors of our first and last terms. So essentially, I'm just going to put them into little columns, okay? And to organize it, I'll put the first terms in blue and the factors of the second terms in green, just so we can see, okay? We also need the products of the numbers we're going to multiply to add up to our b term, okay? Our b term is this a -11x.
Wait, wouldn't you want to find the difference?
So what I'm going to do is trial and error here. So I'm going to take my first pairing, 1x, and I'm just going to multiply it by terms in the second. So I can only multiply one column by one column, okay? It's got to be the terms in the first by the terms in the second. So
a crisscross, or?
We can do both. So 1x times 2 and 6x times 5. 1x times 2 will give us 2x. 6x times 5 will give us 30x. Is there a combination of 2x and 30x that equals -11x? That doesn't work. So we've gone straight across. Now we crisscross. 1x times 5, 6x times 2x. That gives us 12x and 5x. Any combination of that gives us 11x? No. So we know that this pairing and this pairing don't work. Okay? Let's go to the next pair. Same thing. 1x times 10x, 6x times 1x. That's going to give us 10x and, oh, I forgot that, and 6x. Any pairing of that going to work? 10x and 6x? No, that won't work. Let's go across again. 1x and 1, 6x and 10. We get 60 and 1x. Any of that going to work? No. So we've now tried every combination with this first pair. We know those won't work. So we can get rid of those. Okay? Let's go to our next pairing. Our next pairing is 2x. So let's try 2x and 2, 3x and 5. We're looking at 4x and 15x. Any pairing of that work to get to 11? Yeah, that will work. So I'm going to put some permanent lines here now. We'll do those in red, okay? So I know I'm multiplying these. 2x times 2x will give us our 4x. 3x times 5 will give us our 15x. Now, I need to get to -11x, and I have to add.
-50.
Yes, that's right. 15 is going to have to be a negative number, okay?
Same as 5, too.
Yeah, so this is what's important, because when we go to place the factors in, we actually use the numbers from the columns. So whatever I multiplied by my second term to get 15, I need to turn that term negative. So that now becomes negative 5. Now I got to double check. I want to make sure that this does make sense. These were my factors of negative 10, right? Remember, we didn't really talk about the negative before. I just wanted the absolute value of 10, the factors of 10. What is positive 2 times negative 5? Yeah, but not just 10. It's positive times a negative.
Oh, sorry, negative 10.
So that's our check. See how it actually equaled negative 10? So now I know, okay, for sure that works because it does multiply to negative 10. So my next step, I'll come down here. I got to keep my common factor, negative 3. And I can go straight into the brackets now.
We can just say do in bracket.
We're factoring this into 2 different brackets. That's why we have 2 terms here, a 2 and a 3, and a 2 and a negative 5. So it's going to be split. These will be my first terms. I'll put them in blue. So the first term in each bracket is going to be a 2x. One of them is going to be 2x, and the other one's going to be 3x. Okay? And I'll put the other ones in green. My second terms are coming from our other column we used, right? Now this is the trick. Because I multiplied 2x times 2, this 2x and the 2 have to go in opposite brackets. So I have to put my positive 2 in the other bracket. It can't go in the same bracket as the number I multiplied by. Okay, and we'll do a couple of these so you get into the routine. So same idea with the 3x and our negative 5. The 3x and the negative 5, you see, they can't go in the same bracket.
So you only do that if it's negative, or you always do that?
No, always do that. It's just what you multiplied by. You always have to do that. So I'm going to write them in black now. Negative 3, we get 2x minus 5. 3x plus 2. And that's it. I can't actually go any farther. These have been factored. These only have power of 1. So this is as far as I can go with the factoring of this question. Okay, so let's get a full view of this. All right, so let's go. What do I do first?
So you divide everything by negative 3.
Okay, what do I got to check first in terms of steps?
Oh, order of terms.
Are they in the right order?
Yeah.
Okay, good. So you're right. Next thing I do is?
Greatest common factor.
Yeah, so for greatest common factor. So what is it?
So you have to divide everything by negative 3 because the first number can't
Be what?
positive.
Great. It's not that it can, it's just that it'll be easier for us. Okay? So now what do I write?
Negative 3 outside the brackets.
Mhm.
X squared plus negative 10
10 what?
plus 25.
Is it just negative 10?
Oh, sorry, negative 10x
Yes.
plus 25.
Great. Okay. Now what?
Can you do the midterm test on this?
Yes, you can. You can do the midterm test. Oh, okay, let's talk about that. All right, so in our special products, our step 3, we added a little. We called our different squares, so we added our name. And you're right, there is a perfect square trinomial. The reason I didn't write it before is because, like I said, you can solve a perfect square trinomial by the factoring by products. But if you recognize right away it's a perfect square trinomial, then it is faster. It is a faster way of factoring. So let's take a look at this then. Keep walking me through this. What do we have to do to check if it's a perfect square trinomial?
Divide x squared.
Divided by what?
I mean, sorry, square root it.
That's it.
It'll be x.
Okay, so we find the square root of x squared is x. What else?
25 equals 5. Square root.
Square root. Good. Make sure you say that.
Sorry.
That's okay. It's 5. Okay, and then what?
Multiply 5x, 5 and x, and times 2.
5 times x times 2. What do we get?
10x.
10x. Okay. Does that work?
Yeah.
What's the one thing we're kind of missing here with our perfect square trinomial? You notice anything about this 10x and this 10x?
They're not positive.
Yeah. This one is a negative. This one is a positive. What does that mean for us?
We'll have to.
Let's think about this number, okay? I usually don't talk about it till a little later into math, but technically the square root of 25 has 2 answers, okay? One of the answers you write is positive 5. Do you know what the other answer might be?
Negative 5.
Negative 5. Because a negative times a negative still gives us a positive number. So we just had to recognize because this was a negative term, instead of using a positive 5, we actually needed to use negative 5 in here, okay? For our perfect square trinomial. Because now if I have negative 5 times x times 2, we're going to end up with our negative 10. Does that make sense? Okay, so then what do I place into the next bracket then, since we know it's a perfect square trinomial?
Equals negative 3.
Yep.
5x. No. X.
Yeah.
Minus 5.
Yes.
Squared.
Good. That's right. Because this is a negative 5, we put negative 5 in there, and x is our first term. And that's it. You're right. That is faster than factoring by products. I'm going to quickly show you that I could have factored by products and got the exact same thing. Okay, I'll talk through it really quickly down here. So we'll do it in red. So we were still at this step here. Squared minus 10x plus 25, right? We were still here, and you notice there's a perfect square trinomial. I'm going to go real quickly through this. Factors of 1x squared are 1x and 1x. Factors of 25 are 1 and 25 and 5 and 5. I know the products have to add up to negative 10, okay, x. And without even circling them, I can tell you really quickly, if I do 1 times 5, 1 times 5, that's going to give it to me, right? So if I do 1x times 5 and 1x times 5, that's going to give me 5x and 5x. But because this is negative 10, both of these need to be negative in order to add up. So my column, my second terms, both these 5s have to be negative. So when I go to put it into brackets, I have negative 3. We have our 2 brackets. Remember, when we do this style, we always do 2 brackets, okay? My first terms are going to be 1x and 1x. And now, technically, remember our rule, it has to go into opposite brackets. So because I multiplied 1x times negative 5, 1x, I got to put negative 5 in the other bracket, okay?
It would be negative 5 and negative 5?
Yeah, and if you notice, it didn't make a difference, that little trick, because the first 2 terms were the same. But here's the difference, okay? Your teacher's going to want it in this form. Right now, we have it in this form. All you'd have to do, in case you missed it, you still factor this way, and then you look, oh yeah, they're the exact same bracket, so I can just represent it as one bracket, x minus 5 squared. So we still would have got the answer had we done it this way, but you were right. If we noticed that it was a perfect square trinomial, we would have got to the answer faster.
Wait, I have a question.
Yeah. What's the first step we got to do?
Put it in order.
Yeah, is it?
Yep.
Okay, what's next?
Greatest common factor.
Okay.
There isn't one.
No greatest common factor? Right. Good. Now what?
This special factor.
Okay. Is it a difference of squares?
The
difference of squares only has 2 terms. Remember, I have a squared minus c squared?
Oh,
No.
sorry, no.
So it's definitely not a difference of squares. What about a perfect square trinomial?
Yeah.
It could be? Okay, let's try it. Square root the first and the last term. What do we get?
3x and 4. I mean 2.
Okay, so let's find this out. 9x squared gives me 3x and 4,
82.
2. When we multiply them, what do we get?
6.
So 3x times 2 times, what was the other one we had to multiply by?
2.
2, that's right. And that's what that little 2 in the formula is trying to tell you.
Yeah.
Okay? What do we get?
12. Doesn't work.
Doesn't work. So is it a perfect square trinomial? No. So what's our last step to factoring? What do we do now?
Complex. Oh.
Is that what your teacher calls it?
Yeah.
Complex factoring? Okay. I put factoring by products, that's fine. We can do complex factoring. Okay.
Okay, you define the factors of 4.
Yeah. And what other factors do we have to find?
3. That's right, 9.
Yeah, that's right. So let's go through it. What are they?
9, 1, 3, and 3.
Anything I got to put on against those? Or no?
X.
Make sure I multiply by x. Okay.
4, 2, 2, and 4.
And we know what? They got a what?
Alright.
What do we have to do with these numbers?
Oh, minus them. What do you have to do with them?
We got to make sure when we multiply the products,
Oh, equals 15.
they add up to negative 15x, right?
Yeah.
I'll just quickly color code this again. So here we go, column. Alright, so what do you want to try? So, talk me through that trick you know, actually.
So you do 9 times 18.
9 times 2
Sorry, 9
is 18x, yeah, and
1 times x, 2
is
2x.
any combination of that give me negative 15?
No.
No. Okay, let's go across now. Is it going to be any different?
No.
No, because these two terms are the same, right? We're going to end up with the same product, so we're still going to end up with 18x and 2x. So, does that pairing work? No. Let's go on the next one.
3 and 2.
Oh, you're going to jump right to here?
Oh.
I find it's always best to try to
sorry.
exhaust. It's fine if you do it that way, but it gets harder to keep track. So try to exhaust one. So let's go to this one. That way we know we can cross it out right away, right? So 9x by 1 will give us 9x, and what else?
1 times 4 equals 4x.
Does that work?
No.
Let's go across. What do we get?
You get 1x
Yep.
and 27. No,
Close.
36.
Does that work?
No.
Okay, so now what I can do is, I know for sure that's not going to work. But I'm left with this. I know these are going to be my first terms. Okay, so let's keep going. What's that?
3 times 2, 6.
And what?
3 times 2 is 6 also.
Does it work?
No.
And if I go across, is there any difference?
No.
No. So now what I figured out is this column here, it doesn't work at all either.
So it has to be the last one.
It's got to be the last one, but it's always good to check and make sure, right? So let's see the last one.
3. 3.
Any combination of that give me 15x?
Yeah.
Yeah, okay. So I'm going to put my lines. It's always good to remember what we multiplied by, right? So
Aren't they all going to be negative?
yeah, they're going to have to be negative, right? Because in order to add 3 and 12 to get to negative 15, it has to be negative 3 and negative 12. So what do I turn negative now?
Negative. Wait, sorry, again?
So remember, because we have to use negative 3 and negative 12, which of my terms now have to become negative?
Oh, 1 and 4.
Yeah, they both have to be negative, right? And let's double check. Remember my way of checking? Let's multiply them together. What's negative 1 times negative 4? 4. Positive 4, right? And it works, right? We're down to positive 4. Okay, so how do I put this together?
It would be 3x. But can you just do 3x? One bracket, since it's the same number?
The second numbers aren't going to be the same.
Oh,
So it won't. In order to put a number in brackets squared, both terms have to be the exact same in both brackets. So these two would have to be the same, and these two would have to be the same in order to square. If one of them is the same, but the second aren't, we can't square it that way. It has to be two different brackets. Okay? So we have 3x in one, 3x in the other. And then how do I split these?
Would be negative 1 plus 1. Sorry, negative 1 and then 3x plus 4.
Is it? Didn't we use a negative for 4 also?
Oh, sorry, negative 4.
Yeah, we use negative 1 and we use negative 4, right? So because we use both negatives, now remember that rule I told you? The 3x and the negative 1 have to go in opposite brackets. So here's the 3x, negative 1 are opposite. 3x and negative 4, 3x and negative 4. Because these are both the same term, you ended up with them in a 3x anyway. So it's very important though when these are different terms and these are different terms that we make sure we put them in opposite brackets. Otherwise we're going to end up with the wrong answer. Okay? First step, what do we do?
Put it in order.
Is it in order?
Yep.
Yep, we're good. What's next?
Greatest common factor.
Is there one?
Yeah.
What?
Negative 1.
Good. Why did it have to use negative 1?
Because the first number has to be positive.
Yeah, we want to make it positive. It'll be easier for us. So what's written in the next line?
Negative 1. Brackets. X. X4, sorry.
Yeah, that's okay.
Negative 37 plus 37.
Plus 36.
Sorry.
That's okay. Okay. Now what?
You could do the midterm, but it won't work. So.
We know that right away, right? When I square root this, I'm going to get 6 times 1 times 2. We're not getting 37. Right? And we know it's not a difference of squares either. It's not two terms, so that's not going to work. All right, factoring by, what do they call it? Complex factoring? All right, complex factoring. Talk me through this.
So you'd find the common factors of x first.
Okay,
So it'd be x squared and then x squared.
Yeah, so x squared and x squared, good.
Then first 36, 6 and 6, 12 and 3.
Yeah. Keep going. Catch up. 6 and 6, 12 and
36 and 1, 2 and 18.
Yep.
Yeah.
2. What do we got? 1, 2, 3. There's one other one in here.
4. 4 and 6. No.
6. Oh, 4 times that. Okay. That's all of them. Now, I want you to get a little faster at this factoring, so which one do you think is going to work? Quickly looking at it.
How do you know?
What do we got to add up to? Remember the products? Got to add up to what?
37.
Negative 37x.
Oh, 36 more, right?
Yeah, of course, right? If you think about it, especially because these are times 1, we're literally looking at these terms and just adding them. Okay? Because we know 1 is not going to change these numbers, and none of these are going to work except 36 and 1.
Yeah.
So, we know we're going to do x squared, and 36 and 1 are going to be our pairings. When we multiply them, we're going to get 36x. Oh, we've made a little bit of an error in this question. Okay.
You did?
Well, we're coming to the realization now. X squared times 36 is 36x squared. X squared times 1 is x squared. Right? What's the problem? What's our middle term?
37x.
37x. It's not an x squared, is it? No. So I'm unable to actually go ahead and pick
So how do you do it?
a complex factoring. Now, there's 2 things. I'm not sure which one your teacher would want you to do. We can't do complex factoring because, now, if this was squared, we definitely could, and we would get the answer. But because it's not squared, we can't do this complex factoring or factoring by products. There is one last thing you could have done. And we'll do it down here. I'm not sure if your teacher would want you to do it or not. Let's say we already factored out the negative 1. This might be as far, so we'll do it in red, black, what we think your teacher might go, this would be the answer, negative 1, x4 minus 37x plus 36. They might just want that. That's the common factor, and you're finished. Or another option here, and we'll do it in blue. Okay, this is the original answer again. We had negative x4 plus 37x minus 36, right? Another option would be to just group a pairing of them together. So if I group these 2 together, can I take a factor out of just those 2?
No.
Look closely at it.
X.
Ah, yes. We could take an x out of both, right? So if I were to take, and not just x, let's take negative x out. We'll take negative x out of both of those. So now I have negative, we have negative x to the power of 3 plus 37 minus 36. And we can go farther actually from this. Okay, so I'm not sure how far into factoring your teacher wants you to go. But what I can do here is, you guys done anything called a let statement? Let x equal something, let y equal something?
Yeah.
Yeah.
Like for this, these kind of stuff, yeah.
Well, actually, you know what? So sorry, we can't call it x, we'd have to call it a, and then there would be no room for us to go. If I called the bracket a, if I went and said let a equal x cubed plus 37, well then I would just be left with negative x times a minus 36, and there's nowhere I can go with that, right? So your teacher either go here or go here. I would accept the first one. I wouldn't have a problem with that. So I think you're probably all you got to do. Does that make sense? The trick was in this one, I think they were trying to trick you, is that there wasn't a square term here. Had there been, we could have done complex factoring. But it's not till we started multiplying across that we realized, oh, we're working with x squared, and this isn't an x squared term, so we can't do complex factoring. All right.
I would group 6y and 10.
Okay, 6xy and 10?
Yeah.
So let's rearrange them. All right, so we have 6xy minus 10y.
Yep.
Then what?
Negative 21x.
Yeah.
Plus 35.
Good. Okay, good.
You know, please work with one group first, right?
Mm-hmm. What group do you want to work with? So tell me about it.
You can do. Yeah, that's a bad grouping, right?
Oh, no, it'll work. What can I factor out?
2y.
2y, good. So I'm going to work with this grouping first, and I can factor out 2y from both of them. Okay, so we've just set them up in pairs. And same with this one. Now, when I do the factoring by grouping, always leave the sign in between. Okay, so we have a negative sign, leave that negative sign in between, because if I actually put the bracket here, it changes it. It now becomes a multiplication question, which this is not a multiplication question between two brackets. Okay, so if this was a positive or a negative sign, keep that between our groups of factors. Okay, so we took 2y out. What was left inside the brackets?
3x
Mm-hmm.
minus 10. No, 5.
Yeah, minus 5. Now, what about those brackets? What can I take out of those?
7.
Yep.
Negative 7.
Yeah, so it's going to be negative 7 on the outside, right? Because we have that negative already on the outside. When we pull it out, it becomes negative 7. What's inside?
Negative 3x.
Well, because I put this around here, assume this was positive 21. See how I separated it from the negative sign? The negative sign stayed on the outside. And when we took this out, this is positive 21x divided by positive 7. Are you okay with that? We could have thought of it like this too. You can think of this as negative 21, okay? And when we take our negative 7 out, okay. So I know I said that you want to keep a term in between, but you are right. It'll look easier if we can keep this as 21x and we have the negative inside, okay? So I'm going to put the negative inside with the 21. But what you still have to realize now is there's technically a term here. And we're going to replace it with a positive. Because again, if it's two brackets beside each other, we're going to get confused, okay? So it's technically a positive sign in there. Now, we factored out, like you said, you rather factor out negative 7, right? So let's factor out negative 7. So negative 7 does come to the outside, okay? And we're left with what inside?
3.
3x,
Yeah,
right?
3x plus.
Not plus,
5.
but
No, negative 5.
there you go, good. Now what have you created?
Equation.
Yeah, you created an equation. What can we do now in terms of factoring?
We're creating with the 2y and negative 7.
Yeah, well, the reason is because we're taking now a common factor again. 3x minus 5 and 3x minus 5, that's our common factor. So we're taking it out of both of those. And you're right, we group those two together in a bracket, right? 2y minus 7. And then we factored by grouping. Because
That's all. Now we're done.
that's it. There's nothing else to do here in factoring. So we did that together. We took that out as a common factor. And we had the 2y and the negative 7. That was what was left over. We put them together in a bracket. Okay. Does that make sense?
Yeah.
Okay.
Equal.
Good.
X minus 5.
Yeah. So what we got to do here is we got to put a let statement because we have too many brackets to simplify this. So let a equal x minus 5. So what does our equation now say?
A squared.
A squared.
Plus 3a minus 10.
And just put the a's in red so that we know. And the rest of them. So equals a squared plus 3a minus 10. So all we did is replace our x minus 5 and x minus 5 with a. Now what do I do? When we look at this differently, we'll put it a little closer together. What's the first step to factoring? Are they in order?
Yeah.
Okay. So greatest common factor?
No.
Nope. Is this a difference of squares? Perfect square trinomial?
No.
Okay. So what do we do?
Factor by part.
Yeah, or complex factor. All right. So walk me through that. Factors of a squared.
A and A.
Mm-hmm.
5 and 2.
Mm-hmm.
10 and 1.
Then what?
Wait, why do you always put the 10
Equal
on
sign?
the bottom?
Oh, it doesn't matter. You can put it on top.
No, it's fine.
But I like putting the lower number. Actually, I don't even know. I just put it that way. It doesn't make a difference. As long as we cross when we're trying, it won't make any difference. And they both got to add up to what?
3.
3a. All right. So talk me through this. What is the pairing going to be? We know we're going to be multiplying by 8, so it's the only term, right?
So 5a. 5a. 2a.
That's going to give us what?
3.
5a and 2a. How do we get positive 3 from that, though?
Minus 2a.
Yeah, it's got to be negative. So, what do I have to change to a negative?
Negative 2.
Yep. And let's double check. What is positive 5 times negative 2?
Negative 10.
Yeah, 2 and over, right? So, what's in the brackets now?
A.
Okay. And then,
Does it matter what you put first?
not in this one, because remember, these terms are the same, so we can put...
Don't you switch with the highest number first, or
In terms of multiplication rules, it doesn't make a difference. If the teacher's very picky, maybe, but...
So a plus 5 and a negative minus 2.
Plus 5 minus 2. Yep. Are we finished?
Yep.
We are?
No,
What do we got to do?
you have to substitute x minus 5 now.
Yeah, we got to substitute x minus 5 for the a. Yep. That's right. So we got to re-plug in x minus 5. So what do we get? We get x minus 5 plus 5 in one bracket, and so, x minus 5 minus 2 in the other. So let's simplify this now. What ends up in this bracket? This is going to say...
It's the x, right?
Yeah, that's right. I'm just going to show you. We would drop the brackets, x minus 5 minus 2, okay, and then we simplify. We'd get x times what?
Times x negative 7.
Yeah. I'm not saying. Is that factor?
You can't go any further?
No, there's nothing else to factor in. Because this is a term in itself, and it's already being multiplied by this bracket.
Can't you make it x squared though? Because
if I multiplied it back in, that would be expanding again.
oh, okay.
Right? We're trying to factor. Expanding, if I were to expand this now, then I would end up, so I'll do that in red. Expand, that would be x times x is x squared, and x times, so we'd have x squared minus 7x, but technically this is the factor form. This isn't. This has now been expanded. Okay, and this is what they're going to be looking for, the most factored form. So that's what we have for our answer. That makes sense to you?
Yeah.
So like you said, we're going to replace x plus 5 with a, so that a equals x plus 5. So now what do we get? We get
49 a squared.
Yep, minus a squared. Right?
Order.
Yep, let's put them in order. So when we put it in order, what happens? We get
Negative a squared.
Yep.
Plus 49.
Yep.
You have to make it positive, so negative 1.
So we factor out a common factor, negative 1. Very good. Then what?
So it'll be a squared minus 49.
Okay. So
And then you
now what?
negative 1, then you should do negative a minus, no, a plus 5, no, plus 7.
Let's go back to our factoring rules for a sec. Remember our steps? Let me look at something. So we just ordered our terms and we took a greatest common factor out. What are we looking at? Could this be a difference of squares?
Yeah.
Just two terms and there's a subtraction sign. Do you know how to solve a difference of squares?
Yeah.
What do you do on the side?
You'd have to square root
Yeah. Square root what?
both of the numbers, so
Okay.
it'll be a squared equals a.
And?
Negative 49 equals 9.
Okay. You cannot actually find the square root of a negative. So just the absolute value of 49.
Oh, 7.
Okay? Yeah. So it's got to be positive 49 because you can't find the square root of a negative number. So we're looking at 7. Okay. So now what happens when we go to put it into a factor form? We get, always bring down the common factor
Oh,
first.
it'll be a
Don't forget the negative 1.
plus negative 1.
Yeah.
A minus 7.
Okay?
A minus 7. No, plus 7.
Yeah.
Well, why do you do plus 7?
That's the trick. Okay? That's the trick in order to get rid of our middle term. So remember our difference of squared is a squared minus c squared. There's no b, and we're used to, in our factoring by products, to a bx, okay? So we have to put a negative and a positive. And the reason why is I'm going to do it in blue. This is my answer check. So technically we're done. You got the right answer there. I'm going to check my answer by expanding, okay? So check. The check by expanding, we have -1, a minus 7, a plus 7.
We're not done though, right? Because we have to substitute.
Yeah, we'd have to, oh yeah, you're right, I forgot. We're going to substitute that other stuff back in. Okay? We'll have to substitute it in, but let's just check right now that we've got these terms right. So we have -7, +7. Have you guys done FOIL or rainbow method or anything like that for expanding? Well, to expand, I got to multiply this term by this term by that, by this and this, okay? So I'm going to end up with still -1 on the outside. A times a is a squared. A times +7 is +7a. -7 times a is -7a. And -7 times that, -49. If you notice, I have a +7a and a -7a.
Those cancel out.
Yeah, so that's why I have to have a positive and a negative. So then we're left with -1, a squared, minus 49. Does that make sense?
Yeah.
Okay, so we know we've done that, right? Let's continue with our question, because you're right, we weren't finished. We do have to plug stuff in. What do we have to plug back in?
X minus 5.
Yeah. Because remember, a was equal to x minus 5. So let's plug them in. So we get -1, what?
X minus 5.
Mm-hmm.
Minus 7.
Yep.
Then sorry, X minus 5.
Yep. Then what do we get?
X -12.
Mm-hmm.
Minus 12.
X minus 12.
And then X plus 2.
Yep.
And
And then we're done. That's the final answer. Okay?